Good evening, everyone. This is IGCSE Physics, January 2019, paper 1P. In this session, I'll discuss question 5 and 6 with you. This question is about electric motors. The diagram A shows a motor lifting a 780 gram mass. The current in the motor is 0.65 ampere. The voltage is 4.5 volt, and the electrical energy is 25 joules. Calculate the time taken for the motor to lift this mass. So basically, the formula which relate energy, power, and time. We know power is equals to energy divided by time. So time is equals to energy divided by power. The energy and the power, because electrical power is there, so voltage and current, so it will be VI. So energy is equals to 25 divided by voltage, which is 4.5, multiplied by current 0.65. So it will take, this motor will take approximately 8.5 seconds to lift this mass. State the equation which relate the gravitational potential energy mass. So PE is equals to mgh. The potential energy is given 5. What about the mass? It is 780 grams, so the mass should be in kilograms, so we'll divide by 1000, which will be 0.78. Gravity is 10 and the height h is there, so 5 divided by 0.78 into 10, this will give us the height, which is coming out as 0.64 meter. Explain why the amount of electrical energy transferred to the motor is greater than the amount of weight. So normally, because what happened, there is also some of the energy loss due to friction between the energy loss in the form of heat due to friction between the parts, and energy is also used to lift the rope as well. We only calculated the energy used to lift the mass. We ignore the rope, so that some of the energy is also used to lift the rope. The diagram B shows different electric motor. Explain how the current in the motor causes a rotation. So current passing through the wire produces a magnetic field. It produces magnetic field. Magnetic field of magnet interact with magnetic field of wire, which cause force on wire and rotate. A student investigates the motion of a different falling masses by measuring the time taken for the toy parachute. This is the student's method. He measures the mass of a toy parachute, and then he drops the toy parachute from window. Repeat the experiment with additional masses added to the toy. Continue to add mass up maximum 6 different masses. Describe how students should measure the time for a toy parachute to fall from the window. So he should start the timer when releasing the parachute. and stop the timer when a parachute lands on the ground. That will be the time interval for a parachute to move from window to the ground level. State the independent and the dependent variable. So independent because he's changing the mass and the time for the parachute to drop will change. So the mass is independent and the time is dependent, like depending on what is the amount of matter. State one factor that students should keep constant. So you should take a same surface area of parachute or same wind speed, or surroundings wind speed should be same. The table shows the student's result. Complete the table, calculate the average for 120 gram. So that's equal to 0.88. On the grid, plot a graph. So we'll use the table. The average mean time is there and the mass, and we'll plot the graph accordingly. The student noticed that the toy parachute accelerate, then fall at a constant speed. The arrow in the diagram shows the size and the direction of the force acting on the toy parachute. Explain why the toy parachute accelerate then fall at a constant speed. So initially there is a greater resultant force. That's why it is having a greater acceleration. So weight is acting down when parachute fall. It has maximum acceleration. When speed increase, the air resistance will increase, which cause resultant force to decrease. When air resistance balance with weight, no resultant force on parachute. It will move with constant speed. So this was question 6, 5 and 6 from January 2019, paper 1.